The next topic that we are going to start to discuss is called conics. And conics, if you'll take your notes and flip over on the blank side, I would just kind of give you an idea of what we mean by conics. Conics are equations that come from a circle, come from a cone, and we have a lot of different pieces that we can get from a cone. If we look at the top of a cone, if it's a perfect circle, we'll have what's called a circle. If I take a piece of the cone and make a slice on the cone, I might have a parabola. If I take a slice and have two pieces of a parabola, that's called a hyperbola. And then if I take a cut and I cut down on the cone, I'm going to have an elongated circle, which we sometimes call an oval, but we'll call these ellipses. So the study of conics is looking at all different circles, parabolas, hyperbolas, and ellipses. So the first one of these is the easiest, is a circle. So let me give you the standard form of a circle. The standard form is x minus h quantity squared plus y minus k quantity squared equal to r squared. And so our equations are going to look a little different. We're going to have x squareds and we're going to have y squareds, and they're going to equal some number. So let me kind of point out what h and k are. I'll show you how we graph them, and then I'll give you some practice problems. So in a circle, we have two very important pieces. One is called the center. The center is going to be this hk, whatever these numbers are, and r is going to be our radius. So we might remember that a circle is the set of all points that are equal distance from the center. So in this case, what is h and k? If there's not a number along with the x, it will just be 0, 0. And this number on the other side of the equal sign is going to be our radius squared. So to find the radius, we will take the square root of this number. So in this particular circle, we're going to have 0, 0, and our radius is going to be 5. So again, that quick definition of a circle is what? A circle is a set of all points that are equal distance, which is 5, from this center. So to graph one, we'll go 5 to the right, 5 up, 5 to the left, and 5 down. And as smooth as we can, we'll try to graph a circle. And again, most of the time, unless I have a compass, I won't get a perfect circle, but we know that every single one of these points is exactly 5 long. So if I gave you a compass, we could get pretty accurate. Our equations are going to look a little different. You're going to be asked to identify center and radius and graph, and then we might go backwards. So flipping your notes over, let's take a quick look at our first example. And we can see that if we have an x squared plus y squared, if they have no number in it, like in number 3, the center is just going to be 0, 0. The radius is always the square root of this number, so the radius will be 7 in this example. So let's do the best circle we can. Identify your center, go to the radius. The easiest radiuses are right, up, down, right, left, and then as smoothly as you can, try to connect so you get a circle. And again, I won't take off points if you don't have a perfect circle, but just try to get them pretty even. Okay. So again, in number 2, we have a center at 0, 0. Our radius would be 4. Let's jump down to number 3 when it can get a little bit more complicated. Here, we need to identify the center. So the center is x minus h quantity squared. So if this is a minus 1, when we put it into the center, it actually becomes a positive 1. The y point goes with the y. And again, if it's a minus that point, when we put it into our point, it becomes a positive. So how would I do a center of 1 and 1.5? You will go over 1 and 1.5 is our center. And then our radius will be the square root of the number on the outside, which is square root of 1 is 1. So we'll just go 1 to the right, 1 up, 1 over, 1 down, and it will just be an itsy bitsy circle. Okay, so the hardest thing to be is to see the center and the radius, and the form is if it's an x minus 1, when we put it in here, if it's an x plus 1, the form is x minus h quantity squared, so a minus minus. So our center will be actually at a negative 1. If it's a plus, we'll make it a minus when we translate out. So a negative 1, negative 2 would be our center. Our radius will be the square root of 9, which is a 3. And the easiest thing to do is go 3 to the right, 3 up, 3 over, and 3 down. As smoothly as you can, graph your circle and call it good. The second type of problems are what I call backwards problem. I will give you some information and I'll ask you to write the standard form of the equation. So the standard form again is x minus h quantity squared plus y minus k quantity squared equal to the radius squared. So when we're writing out these points, if we have 0, 0, those are just 0, 0, so we just have an x squared plus a y squared. And then the form is the radius squared. So you'll have to square that number. 10 squared, you should know, is 100. I've changed 7 and 8 around a little bit, but number 6, again, if the center is 0, 0, it's just an x squared and a y squared. The radius squared, 12 squared, is 144. Okay. So if you have not changed number 7 and 8, change that. I wanted to make them a little bit harder. And here we want to put in the standard form. Since the center is not at 0, 0, I'm changing this. We're going to put in the x point goes with the x quantity squared, and the y point's going to go with the y quantity squared. Equal to the radius squared. 7 squared is 49. And the way that I remember this is that our form is x minus my x point, so I get an x minus 1, and y minus our y point, so y minus a minus 5 is actually going to become a plus 5. So when we're looking at standard forms, we'll always have this as the radius squared, and then for our x quantity and our y quantity, we'll have our x and our y point, and I basically remember the x goes with the x. If it's negative, it's really positive. The y goes with the y point, and if it's positive, when I put it into the equation, you might see that as negative. So make sure that you bold this. This is your standard form for a circle. Today's exercise will be practicing those, and then we'll go from there.